Hello and welcome to TidyX episode 45. TidyX is a screencast where we go through and explain how our code works. My name is Ellis Hughes, and you can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward, and you can find me on Twitter at OSP Patrick. And you can find our screencast on Twitter at tidy_explained, or you can hit us up on Gmail at tidy.explained@gmail.com. And
Or leave
you
a
can
comment.
also comment on the YouTube page.
Yeah, because we definitely see them. We thank all the comments that we see there, all the emails that we get. Really appreciate it. Want to make sure that we're providing content that you find valuable.
Yeah.
So please let us know if what you're seeing is hunky-dory or if there's something you'd like us to cover, because
Yeah, for
we
sure.
have a lot of fun putting this together. We always learn new things as we go through and put these videos together. So definitely want to hear what y'all have to say.
Yeah. And speaking of covering topics, today we will cover kind of like a hodgepodge of stuff that we did over the past year. So we're at episode 45. We've done one a week since basically
March.
March.
Yeah,
So
March of 2019. 2020.
we're
Okay,
yeah,
wow. 2020 is a weird year.
yeah, isn't it? Yeah. So we're nearing in on a full year, which would be um, a couple more episodes, and we're basically there.
Yep.
So this week we're going to cover a hodgepodge of different things that we talked about across the year: web scraping, regex expressions, for loops, visualizations, models, all that stuff. And we're going to do it in celebration of opening day of hockey. So the hockey season just opened. As I've said on the previous few podcast screencasts where we've gone over, Plotly and things like that, we've used hockey data. I'm really trying to learn more about the sport and get into it this year in preparation for our own team, the Kraken, next season. So really excited about that. So
Yeah.
I scraped a bunch of team data from hockeyreference.com. We're going to go through that, and we're going to go through just some ways of looking at goal scoring across teams, across seasons.
All right. So I've shared our screen now. So now everyone can see the screen. And Pat, you can also see the screen. So this is...
I can see the screen.
All right. So we're in a normal R Studio session here, running R. And we'll go through it. So the first thing we do, as we always have to do, is load in the libraries that we're going to be using for the rest of our script here. So we're loading the Tidyverse package because it's got all that fun, delicious data manipulation tools. RVest, we're going to use that to do our web scraping, and ggalt, which do we use that one?
I used it for something, and right now
I don't know. We'll see. We'll see if we...
Yeah, it's escaping me. Why did I use that?
All right. But anyway, so now we've got all three loaded, and then we're going to set our theme. So this is going to set it so the rest of our GG plots will be using the same theme, so we don't have to go back and add it to each one of them. And we like to use a theme light theme, which kind of just makes it a little bit nicer, takes it away from the default theming of GG plot there. Cool. So now we've got our kind of environment set up. So now we're going to pull in the data. So what we're going to do is we're going to be scraping, and this seems a little counterintuitive. We're going to be scraping the 2019 season and calling it URL 2018, and the 2020 NHL 2020 URL and calling that URL 2019.
Yeah. Well, the NHL names the season for the second year because the season eclipses the change. Yeah. So it's always 2018, 2019, 2019, 2020.
All right. So we're going to do that. And so let's just take a quick peek at what the tables look like. So this is what the tables, the website that we're pulling from looks like. So it's basically a lot of different tables. So Eastern Conference and Western Conference, League Playoff Series, team stats, analytics. So lots of delicious data here. But what we really care about are these two tables here. So what we're going to do is we're going to first go in and we're going to go, okay, we've read that website there. Okay, we're going to call the function HTML table. What HTML table will do is will identify all the tables that exist with the table tags in HTML and pull those in and convert them into a list of data frames for us very nicely. So it's a very handy function to be working with. I mean, realistically, when you're working with web scraping and you're really interested in pulling out the tables out of websites and that's it, and you know that it's a table, this is like the easiest way to do it. You don't need to worry about going through and knowing all the underlying HTML and whatnot. HTML table pulls that out all for you. But we know that we want to pull, so let's just take a quick peek at what this looks like. Head let's just do it. Let's see if we can do a view on the list. Boom.
There you go.
So what we can do is we can kind of peek through this, and so this is going to be that first table, which is the which that would be the Eastern Conference here.
Yep.
Right, this first table. And then the second table here is the Eastern Conference?
The Western Conference?
Yeah, and then here's a bunch of additional tables that it identified through the HTML here, but we don't really care about those. We don't want to mess with those. So what we're going to do is you can subset a list by its elements. So what we're going to do here is we're going to take the list of tables. What we really care about are the first two tables that exist, so 1 to 2. If I wanted to pull out the first 3 elements of or subset the list to keep the first 3 elements, I do 3, 5. You could also do like a vector of 1, 5, 7 if those were the tables you wanted to keep. So we're going to do 1 to 2. So we want to keep those 2 tables there and bind them together. So it combines the 2 different tables into a single table for us. Using the bind rows, we're going to call as data frame on it, so make sure that it's a data frame. We're then going to select just the fields that we care about keeping. So we want to keep the first column, which is the team column. However, because of the way that it gets read in, it doesn't recognize that it doesn't have a column header calling it team. So it has ... .1 when it gets read in. So we're going to call that team. Then we've got games played, wins, losses, goals for, goals against. So now we've subset our tables there to only keep a smaller subset of them. But one thing that we've talked about regularly with these reference sites is they tend to repeat their headers throughout, and we don't want to have that. And so we're going to filter out any rows that contain the contents Atlantic Division, Metropolitan Division, Central Division, and Pacific Division, because those don't contain any information that we want to be keeping there. We're going to mutate. We're going to convert all the columns that should be numeric into numeric. So that is, so we're going to use across. We're going to go across all the columns between games played to goals against, and just convert them into a numeric value. And then finally, so let's take a quick peek at what this looks like. All right, so now we've got this data set here. But you'll notice that there's some asterisks here. So that means a team went to the playoffs that year. So what we're going to do is we're first going to make sure that we don't lose any information. So we're going to label them as a playoff team. So what we're going to do is we're going to use this mutate and call it a grepl. So this returns a logical value based on the regular expression that you pass. And if it finds that if it identifies that regular expression inside of that string, it returns true. Otherwise, it returns false, and it's vectorized. So we're going to call, look for this asterisk in the teams column, and we're going to use the argument fixed equals true. So this means that it won't actually try to apply the regular expression. It'll only look for the exact string that we pass to it, because an asterisk is a wildcard inside of a regular expression, which tells it to match 0 to infinite times. So this will say, no, actually look for that star inside the teams column, and if it does find a star, mark that as a playoff team. And then we're also going to remove it from the teams column, so that way we don't have the asterisk in the team column anymore. So this is going to identify when an asterisk appears and remove it from it. All right, so then we've done that for 2018. So now we've got our 2018 data set here all prepped and ready. And we're going to do the exact same thing. So I'm not going to go through it again for 2019. So now we've got 2018 and 2019 all prepped and ready for us to start doing some Pythagorean stuff with it. So Pat, you want to take us through this next piece?
Yeah, so we're gonna. The first thing I wanted to know is which teams underperformed and overperformed their expectation. So we're going to use the Pythagorean wins formula. We did this on baseball when we introduced for loops in TidyX 23. So you can reference a more specific conversation about that. But basically, I'm going to build this on the 2018 data set. So we take our 2018 data set, and I'm going to create a scoring, 2 new columns. I'm going to create a scoring ratio, and I'm going to create the true win percentage. So the scoring ratio is goals for divided by goals against. And then the true win percentage is how many games that team won, specific to the number of, obviously, games that they played. And so we create those 2 columns. And the Pythagorean win formula is the scoring ratio raised to an exponent divided by 1 plus the scoring ratio raised to that same exponent. So we don't know what the exponent should be. We could Google around, obviously, and find what people have used. Different sports have different exponents depending on the scoring environment within that sport. And exponents can even change over time depending on rule changes that change the scoring environment of that sport. So we want to find out the exponent that is most useful for our data. And when I say useful, what I mean is the exponent that helps us identify the optimal mean absolute error, the lowest amount of error between what was observed and what was expected. So I start by doing this as a sequence of grids. So I create this sequence from values 0.5 to 4 by tenths. Basically, what I'm saying here is I don't know what the exponent's going to be. Just kind of Googling around and knowing other sports, it's probably going to be somewhere within this range. So try every one of those options. And I take that exponent, and then I create this basic like table that says hey, we're going to deposit all of the results from our optimization for loop into this data frame. And then I get the key columns out of our 2018 data set, which is, wins and games played, wins, loss, goals for, goals against. And I create the for loop. So this is going to do the heavy lifting for us. So the way that this works is I say for I, which is going to be the exponent. We could have used any letter we want here. But for I in the sequence of the exponent options, which is the values.
This is the index for all.
Yes. That's the index. Yes, it's going to go through each of the values within that exponent option. But it's saying sequence along those. So it's going to sequence through 36 times. It gets those key columns that we selected, and it calculates the observed win percentage. And then we make a predicted win percentage. So we create the scoring ratio raised to the exponent of, again, option 1 through 36. It's going to go through each one. And divided by 1 plus the scoring ratio raised to that same exponent option, 1 through 36. And it's going to deposit each time. It's going to deposit that value into our mean MAE.results data frame. And what it's depositing is it's depositing the I value into row I for column 2, which is where we store the mean absolute error, which is right there is the formula, which is the absolute difference between the observed win percentage and the predicted win percentage. We're trying to find the value that minimizes that result. So we'll go ahead and run this for loop, and we can look at the results. So there we see for exponent 0.5, the Pythagorean win expectation had an absolute error of 0.06. And then you can see that it starts to descend down. We can actually visualize the results across all 36 of those options. And we'll...
So let's quickly step through how we make this, though. So we're going to take the results. We're going to throw it into our ggplot. We're going to set our aesthetics to be the x-axis is the exponent. So 0.5 all the way up to 4. Y is the results, which is essentially the MAE for each exponent so that we can visualize how it looks. We're going to use a geom line because we're going to want to draw a line across all of those so we can kind of more easily visualize it. And it's going to draw a line between each point there, essentially. And then we're going to set our labels. The x-axis is going to be exponent, y-axis is going to be the MAE, and title is going to be what we're plotting.
And there we go.
There you go. So you can look, it's drawing a line between 0.5 and 4, and it really has a nice U shape there.
Yeah, and we can see that there is a point indeed where we minimize the error, where an exponent minimizes the error, somewhere between 2 and 2.5. So we can subset out the value. So we take that data frame and we say whenever the results equal the minimum value within that results column, we find that the exponent was two. Oh,
sorry,
there it was
go.
2.2. And the result was the minimum, the mean absolute error was 0.0, basically 0.02. Mm-hmm. So let's go ahead and grab that 2.2 exponent. Just in Googling around, I found people in hockey seem to have 2.19. So we're right around the same value that others have found.
And look how little effort we put into getting this.
Exactly. We didn't do anything.
We let the for loop figure it out for us. We don't have like thousands of values that we're checking, but we got super close to what is industry standard, or at least what we could Google and find.
What I could find on the internet. Yeah.
I mean, maybe not an NHL analytics team would say this, but like online,
right.
What's available.
Yeah.
We got really close to that with a very simple grid search.
Yep. Yeah. So we can use that exponent now, and we can make a projection on the expected wins, and then get the difference between the observed wins and the expected wins. So how are we doing this? We're putting we're creating the Pythagorean win percentage as, again, the scoring ratio to the optimal exponent, 2.2, and then dividing by 1 plus the scoring ratio to the optimal exponent. And then the expected wins is going to be that win percentage multiplied by games played. And the error is the observed wins minus the expected wins. And so now we have those new columns in our data set right there. So we have expected wins, and we have absolute wins, and we have the Pythagorean win percentage. We can take a look at a histogram of the error, and there we see generally we have a whole bunch of values right between about 2 games off, plus or minus 2. We have a few teams that outplayed their expectation and a few teams that underplayed their expectation. So we might be initially thinking, well, these teams could have had some chance, luck fall on their side, or maybe they, played in a game where a premier player, a premier opponent got kicked out of the game or put in the penalty box late in the game. And, something might have happened where they had some luck go their way, and those teams might be ripe for a regression to the mean the next season. Right.
Mm-hmm. Same with these players or teams to get better too.
Regression. Reversion to the mean, yeah. So either it goes up or down. Doesn't necessarily have to regress. You could go up to the mean as well. But so here we go. We're going to put this into our 2019 data now. So we're actually going to then visualize some of this. So we take the 2019 data. We again create our scoring ratio, our win percentage, our Pythagorean win percentage, our expected wins, and the error. So all the same steps, all in one for 2019. We get our error, our histogram of our error, a similar type of stuff. We're about, much of the data is right around 1 game off, plus or minus. There's some data in 2 games off, and then nobody's up to 6 games off, so like they were in 2018. And it might be a function of just they also played less games in 2019 due to COVID, and it was a kind of a unique year.
Weird year.
So now we have that data. Let's go ahead and look at some year-to-year comparisons. So the first thing we do is we'll take this 2018 data. We're going to join it to 2019 by the team column, and then we're going to say every other column just add this suffix, either 2018 or 2019, depending on which data frame it came from.
So let's just do a quick view on that, just so that we can demo. So this is suffix. So normally if you don't have suffix, it would add a .x and a .y. So .x to 2018 and .y for 2019. Yeah. I find using suffixes makes it a little bit easier to compare it more easily, so that you don't need to remember, oh wait, .x is, which one was that? .y, oh shoot, which one was that? Now you actually have it labeled.
So now we have all the data labeled by team from one season. So basically year to year plus one, right? So now we have, like, we could do something like we could call a table function on this data and do table playoff team in year one and playoff team in year two and see how many teams actually make the playoffs one year to the next. Hockey's unique. There's a lot of teams that make the playoffs. So I would expect this value to be relatively high. So true and true. 15 teams made the playoffs in year one and then made the playoffs in year plus one.
Yeah.
Which is a lot.
And then, so the years, only one team didn't
make it. Yeah, made it in 2018 and didn't make it in 2019. Mm-hmm. And 9 teams jumped up into the playoffs.
Did they expand the playoffs then?
After not making it. I don't know. Maybe 2019 had some weird things because of COVID. I don't know how they. Yeah, I'm not sure. It's interesting.
I'm wondering.
Oh, you're going to give it a title.
Well, I'm thinking. I don't think I've done that. No. I was getting too optimistic.
You can do it. I think it can't be a number, though. It has to be a character.
That would make sense. There we go.
Yeah, there you go.
2018. If they didn't make it in 2018, 6 teams didn't make it both years. I'm just making sure that we were reading the table.
Yeah, properly. And then 9 teams didn't make it in 2018, but did make it in 2019.
Yeah, so they must have expanded the playoffs because these numbers would have to be the same in order for them to have not expanded it.
Correct. Yeah, that is interesting. I wonder. Huh. Well, there you go. Then we have some year-to-year plots. You want to go through some of these?
Sure thing. So we're going to compare the wins for 2018 versus 2019. So NHL Compare, which has all that data. GG Plot, we're going to set the aesthetic X to be the wins 2018. This should be Y equals wins for 2019. We're going to use points because we're just looking at a single team. Each point represents a single team. And then we're going to use a geom smooth because we want to look at the trend between that to see if there's a trend line in there. We're going to use the method linear model, so it's just going to basically draw a straight line for us. Mm-hmm. There's obviously a bunch of different methods you can use, but what we care is the straight line.
You could also color the points by playoffs, but in one year versus the other. Like, there's all kinds of options.
So many choices. Yeah. But really what you're seeing here is, I mean, it's kind of randomly distributed around the line here, so that's nice. There's some teams that obviously outplayed their 2018 wins versus 2019 because they're above, or at least they're above that prediction line. Chunk below there. There's this I
think that's here. Tampa Bay. That's Detroit.
Yeah.
Who continually is
so now we're
bad.
Gonna do the same thing. We're going to now add an AB line. So this is just a line where it's going to be at 0. So it's going to have a slope of 1. So it's just going to draw basically a diagonal line there. Yeah, we're actually going to look at win percentage this time. So this will take into account the number of games played as well. And then add another GM smooth. And we're also going to use GG repel to label each of the points with the teams. Oh, okay.
Busy.
Busy.
There we go.
That's a little bit better.
Yeah.
So Tampa Bay, way over here on the right. So they won a lot in 2018, and they continued.
I think they won the championship in 2018, and then Boston won it in 2019. So the AB line, right? The line of equality there, which is a intercept of 0. So an intercept basically where it crosses the y-axis, and a slope of 1 that we've set. If the team was exactly as they were in 2018 as they are in 2019, like a good example might be the Ottawa Senators there at the left, they will be right on this line. They basically repeated their performance exactly. A team that is below the line, for example, Tampa Bay, they played really good in 2018, and then they played below that in 2019, whereas the Boston Bruins played better in 2019 than they did in 2018 because they're above the line. So you could see that they played just under 60% win percentage in 2018 and just over 60% win percentage in 2019. So the line of expectation basically just gives us a visual on how well a team did from one season to the next. Yep. Whereas the regression line is the line of best fit, which is identifying the relationship that minimizes the error between the 2018 win percentage and the 2019 win percentage.
Yes, exactly. Mm-hmm. So yeah, and then one thing, so let's bring that out a little bit, and then we've got, where did it go? There's this last plot here where we were curious who was that team down there? Is it Detroit?
Detroit, yeah. Blah, blah. So I think they're like in total rebuild mode from what I've read, which is why they're so far down there. But
yeah, womp womp.
Yeah.
Sorry guys.
Yeah.
Alrighty. So
all right.
Got that together.
And so we'll talk a little bit about regression or reversion to the mean. This is like the famous concept of originally from studying heights, right? Like a father is 6'6", but his son doesn't come out to be usually 6'8". He tends to be a little bit shorter than his father. People tend to revert to the mean. So if you're below the average, the next year, for example, in sport, you might tend to be pulled up to the mean a little bit. And if you're above average, the next year, you might tend to pull down a little bit. Mm-hmm. Teams move up or down around that mean line. So we're going to get a goals for data set here, which is basically just teams and then goals for in 2018 and goals for in 2019. And that's what we're going to look at. So the first thing that I did was I created a new variable called the difference to the mean of 2018. So how far off was each team's goal scoring ability in 2018 relative to the mean in 2018? And so you can go ahead and run that and then plot it. We're going to take that same data set. We're going to put it into a ggplot. So we have the 2018 difference to the mean on the x-axis, and on the y-axis we have the teams. And we're going to do a little column plot here. And we're going to set the v-line at 0, which is going to be, obviously, if you were 0 difference from the mean, you're going to be 0. You're going to be right on the line there. And then I'm just going to throw in the labels here, which is basically the value of how far off, how much better in goal scoring were you than the mean. So here
it'll draw this little box here that we're seeing.
Yeah, the text box.
Yeah.
So we see, for example, Anaheim Ducks in 2018 were about 48 points in goal scoring, goals for 48 goals below the mean, and Tampa Bay Lightning, who was the dot that was way pushed off to the right for 2018. I think it was like over 70% wins. They were basically 78 goals for better than league average, which is
they almost doubled
pretty amazing.
The next team.
Yeah. I mean,
that's insane.
They're like by far and away. That's pretty incredible.
Yeah, that's not like just a minor thing. That is like whooping.
Yeah, that is pretty nuts to see the magnitude of difference that they were. So that obviously that's one way to plot it. We also did a little regression plot here, which is what we're then going to build a linear model based on. So here is the same regression plot, just goals for, goals against. There's the teams. And the idea is we want to actually calculate an equation that fits that regression line. So where does that regression line come from?
What is this thing?
What is that thing? And so we do that by building a linear model right here. So I built the linear model as a linear regression where we're trying to predict the dependent variable being goals for in 2019. So the goal scoring ability in 2019. We want to predict that based off of the difference that the team was in their goal scoring ability from the mean in 2018. And so if we run that model and we run the summary, so we have an intercept of 210 and we have a difference to the mean coefficient of 0.38. So basically what that's saying is for every 1 point value that a team is above the 2018 average of goals for, that increases their goals for in 2019 by about 0.38 units. Mm-hmm. And we see that this model, if we go down to the multiple R squared, explains about 20, adjusted R squared is accounting for the number of coefficients in the model. It's explaining about 20% of the variability in goal scoring in 2019. Now, we could have done this by just looking at goals for in 2018 relative to 2019, which I think we have right there. Yeah. And you'll see that the coefficient is exactly the same. You'll see that the adjusted R squared is the same. You'll see that the p-value is exactly the same. The only difference here is the intercept. And the reason why I wanted to show this was the intercept in our first example above, that is 210, that intercept is normalized to the difference between the team's goals for and the average goals for the league. And so in that way, the intercept is interpretable because the intercept is telling us if the difference to the mean in 2018 were 0, all we would be left with is the average for the league, which is 210 or 211, I guess, if we're rounding up, right? So that's directly interpretable. If we use the second model, it's going to get you the same result. If you were to predict values, you would get the exact same predictions. You could see that the only thing that's changed here is the intercept, really. But this intercept is not interpretable at all because what it's telling us is if goals for in 2018 were 0, we would expect the team to have 116 goals for in 2019. But goals for in 2018 can't be 0. No team didn't go through the season scoring 0 goals. At least that I'm aware of. That would be really weird, right?
Like pretty impressive.
Right.
I'm not even mad. I'm impressed.
Exactly. You'd be so bad, right?
To not score now, didn't you?
Exactly. So we use the difference in our equation as a way to make the intercept more interpretable and more logical, I guess, for us to interpret the values from. Yeah. Okay. So we're going to throw the predictions from our model back into the data frame. So we predict the goals for in 2019. We're going to calculate the residual here. So the residual is going to be the actual goals for in 2019 minus the predicted goals for. And we can plot these residuals, obviously. So we can look at the predicted values relative to the error. So the fitted values relative to the residual. And we can get a sense for what these look like. This is like a common way, model checking in linear regression. Mm-hmm. So we can see which teams have the largest amount of residuals. We see the Detroit Red Wings down there.
They really underperformed.
Yeah, Columbus is down there. And so we can actually then plot these in a way that allows us to evaluate them in maybe a little more interesting way. The next one is a column plot. We did that before. One up. This we did before. It's the same column plot that we did. It's cool, I guess. It's not super interesting, I suppose. The next one, I think
New York really outperformed what they were predicted to do based on 2018.
Yeah, correct. Detroit underperformed. San Jose, Columbus, Ottawa, those were teams that really underperformed what we would have projected. The Tampa Bay team is right in. You could see actually this is really interesting. So it projected them to be pretty close to what we would have seen, even though they scored 80 points in
80 points more.
80 points more than the mean. Yeah, exactly. Yeah. So I thought that a cooler way to do this, we've done this before, is Dumbbell Plot. So we take our data set and we feed it a X start and end point. So in this case, we're going to feed it the starting point of what was predicted for 2019 and an endpoint of what actually happened in 2019. And we'll reorder the teams based on their 2019 goal scoring ability. And the GG dumbbell is where the GG alt package comes from. Now I remember why we loaded that.
Makes it a little bit easier to draw a dumbbell. than
Exactly.
doing it ourselves.
Exactly. So the dumbbell plot here, the color is the color of line between the 2 points, the start and end point. The size is the thickness of the line. The size of X and X end is going to be the thickness of the dots. The color of X end and X start is we're going to change the colors here because we want to be very explicit about what was predicted and what was the observed. So we set the predicted to be blue and we set the observed to be red. And since a legend isn't automatically made for those two colors, I'm going to make one by using annotate.
We had somebody also demo this type of technique in a prior episode.
That
was really cool.
It was pretty cool. I guess the only thing I would add to this, and I couldn't find the right Alt key on my Mac, was if I could put a dot. So in front of the label that says predicted goals or actual goals, like the little Alt dot. Yeah. But I couldn't figure out what I probably should have Googled. But anyway, so I use annotate here. Annotate is basically a way for us to put text or figures explicitly into a graph. Any geome, correct? Yeah, onto a graph. So in this case, I'm using text. I tell it exactly where on the x-axis and y-axis I want it to sit. I tell it what I want to label. So in this case, actual goals or predicted goals. And then I feed it the color of the dots so that it really pops out and says like, hey, when it's blue, it's predicted. And when it's red, it's the actual, the observed. Yep. And then to give it context, we're going to throw in a geome V line at the mean goals for of 2019. So we can see where a team's actual resided. The theme I set to classic because I wanted it to be much cleaner than the theme light, because I wanted to explicitly put in my own grid lines, which are just the y-axis grid lines. So I only wanted the horizontal lines. And I put them into this very light gray color so that they don't take the viewer's eyes away from anything. And here we see, boom. So now we see, for example, Detroit, they had a predicted goals of a little over 200. And they really underperformed. I mean, less than 150 goals scored. I think they only won like 15 or 16 games, I think.
Sorry, guys.
Yeah, really rough. There you could see Tampa Bay predicted versus their actual. They did pretty well. We weren't far off from what we would have expected. Some of the other ones, San Jose Sharks really underperformed. I think they're 1, 2, 3, 5 from the bottom. So the length of the line is showing us the magnitude of error in our projection from our model relative to what the team did. So, you could take this and think about, I guess players on the team, if you were to replace certain players, how many goals are certain players worth? Can you bring in more value? Maybe COVID had something to do with this, where some teams were missing players because they had to sit out due to illness. And so they weren't able to contribute as much. Like there's all kinds of things for the 2019-2020 season, I guess, that make this a bit messy. There was a stoppage, wasn't there? Like I think they started the season and they stopped for a while. Then they went to a bubble.
It was all over the place.
So some of this
2020 was just like
everyone figuring it out. Exactly. So some of this could explain, the kind of observed differences. At the top part, you also see teams that, like New York Rangers right there. They actually had a below average projection, but they overcame that and they outplayed that projection. And so that's really cool. It looks like, where does it go? It looks like right around Minnesota Wild is where the teams flip and started to be underplaying a little bit more. The Blackhawks are nearly dead on with their projection.
Blackhawks. That was Montreal Canadiens.
Oh, Canadiens. Sorry. Yeah. Blackhawks are the one below it. So anyway, it's a cool way to kind of visualize the predicted versus actual. And so that's a little bit of NHL stuff. I was going to work a little bit more on how many points actually equal one extra win in the season. So that would be able to tell you like how much better do you need to make your team in order to win one more game or 10 more games or something like that. But
what it gets you.
Yeah, exactly. What it yields. Maybe we'll do that in another episode.
For sure. Yeah. Let us know if that's what you'd like to hear down below. Send us an email, Twitter, reach out to us.
Yeah. At Tidy Explained. Hashtag us. Send us info.
At us.
At
Sweet.
us. Yeah.
Sounds perfect. Well, I think that was all the content that we have for this episode. Yep. So I think we're going to have to end it here, but we're really excited to be doing these 45 episodes. Now being able to go back and go, here's content from each episode that you can be pulling in to pool together to come up with more analyses. So we're thrilled to be at this point. So with that, we're going to end it. As always, my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And I'm Patrick Warden. You can find me on Twitter at OSP Patrick, and you can tweet us at tidy_explained, or you can email us at tidy.explained@gmail.com, or you can comment on the YouTube page at the bottom.
Subscribe
to
get notified when we release new episodes.
Yep. And send us questions or comments or thoughts, and et cetera, et cetera.
Sweet. All right. Thank you so much, and keep on exploring your world.